And we are live. Let's get fired up here. Okay. Hope you're having a good week. Hope y'all are staying safe out there. APS guys, please really be careful. The heat's really extreme right now. We've had it for over a month. It's not over. We still got a lot of time to go. Make sure you're drinking water, taking care of yourself, looking out for each other. This is just, we're in the middle of a heat wave. Happens every year. And understand this too, when working with customers. Um, Everybody always gets upset and frustrated around this time of year. It's kind of natural. It's what happens. What we have to do is just try to manage that with the customer as best we can. You know, our schedule gets overloaded. We're not going to be able to respond as quickly. And so when we are there, they're going to be a lot more apt to wanting us to stay there. Anyway, the point is, this time of year, if everybody always seems frustrated for some reason, it's because they likely are, and it's just the time of year in our season. So just be mindful of that, be patient. It's not a personal thing at you, it is just the nature of our industry. And just when we have heat waves like this, especially when they last an extended period of time, weeks on end, this is how it goes. What's nice about it is, this is kind of this ebbs and flow pattern I see with service season. So, at least here in Texas with us, we see the first heat waves start to push in somewhere between like April and May. By May, we actually start to see the heat push into the area. So things get busy, things get ramped up. Then by the time July rolls around, we're completely overloaded, overwhelmed, and things are just getting tight and tough. So in that time frame, our schedules are stretched. Our overtime just gets really crazy. It gets a very difficult time of the year to manage. So that leads to customers getting really frustrated, which also leads to us in the field really having a hard time not being frustrated because we're exhausted, we're tired, and we're dealing with cranky and just in some cases unrealistic customers. So anyway, that continues till about October. Somewhere around October time, we're going to see it slow down. We're going to see it settle down. And we'll start to catch up on some of the workload. Things will start to kind of turn around a little bit. Then uh, between October and April, everything slows down enough where we'll be able to take care of most work fairly quickly. Customers will settle down. Everybody calms down. They forget about what happened last summer. And then we roll back into May with kind of a fresh start, if you will. And it takes a couple of months for things to build up again, and then they get riled up again. My point, this is normal. This is our industry. This is just how it goes with us. So just bear that in mind. Be patient, manage yourself, take care of your health, take care of your hydration. Watch out there. Now, hopefully you've already been observing the screen here. This is our scenario for today. We're going to do another troubleshooting exercise. We're going to keep these going for a little while. And just, yeah, we've had a really good response from everybody. APS guys, y'all have all said y'all really enjoy these. So we're going to keep pushing them. Today, I'm shifting into an RTU troubleshoot. So think of this as a package unit, 5-ton, sitting on the roof of a commercial building. And we're going to come up here and troubleshoot this. The call is it's not keeping up. It's not cooling very well. We got a hot space, and I don't know why. So walking into the call, you're up on a roof, you're looking at it. What are some things you need to start evaluating from here? You've obviously hooked up gauges. You've taken some baseline readings. Our evap saturation is 48. We have the evaporator superheat of 15. Outside air is 100 degrees out with a return air of 80, supply air 65. Our condenser saturation is 120. Our liquid line subcooling is at 12 with a discharge superheat of 40. So what are some basic things we can start to try to work through? What's our starting point? And we go back to the same things I've been saying. You've got a list of possible options that could affect you here. You have to pick something, right? So if we don't know, like say you look at this and you have absolutely no idea Where do I go with that? I've never even seen those readings before. That's okay. Pick one of the solutions you do know and start trying to work through it. So things that are easy to eliminate, we're not tripping high pressure, we're not tripping low pressure. So those can be eliminated, which eliminates, maybe dirty coils. Or dirty condenser coils, maybe eliminates a condenser fan issue, possibly. You don't hear any noise, and so the first thing to do, start taking measurements with your senses, as well as your gauges. So your ears are an incredible measurement tool. Do you hear any bearing issues in the condenser fan? Do you hear any weird noises in the refrigerant circuit? Um, so yeah, what are some of the things we can work through? So I see temp drop is 15 degrees. Yes, it is 15 degrees across the evap. Airflow is a little high. Okay, so let's start to troubleshoot through that. By the way, James, I have not forgotten about your emails, but yet I have not responded either. Just letting you know, you're still on my radar. I just haven't got there yet, but I'm sorry. Um, anyway, so airflow is a little high. So we think, okay, could a high airflow cause this issue? So when you have excessive airflow, um, the supply air is not going to drop down properly. So with 65, we're moving too fast through the coil. That's going to affect our flow there. We would have an elevated saturation and an elevated superheat. So that is true, because we've been putting more load into the coil, and so it's going to cause those readings to elevate. Yes. Um, let's see. So that's on the evaporator side with the airflow. What would that do to our condenser side? And we're going to see a little higher load. So we'll see a 120 saturation. So we got a 20-degree over ambient. Um, liquid line subcooling is 12 with a discharge superheat of 40. Okay, so genuinely, there's a strong case to be made for high airflow. There really is. So let's do that. Okay. So you go around to the blower section, you check it, and we're on a medium speed fan. We said we got a 3-speed in this particular unit. We're on a medium speed, and the filters are okay. They're not in bad condition. You don't see anything else. The blower housing itself is okay. So doing just a visual inspection as we're looking at this and trying to determine what we're doing, everything looks okay. Your belts are okay, your pulleys are okay, your current draw on your blower motor is doing fine. It's within RLA. Um, so what do we do? Do we want to drop the fan speed by 1 speed? Let's say we do that. So we go from, say, a medium speed to a low speed. And the only change we really see, our saturation doesn't really fluctuate too much. Our supply air temp might drop a couple of degrees in this particular scenario, but the overall result is it didn't fix our issue. By dropping the fan speed, this particular situation, it did not correct it. So what we did there is you made a fairly accurate diagnosis with a high fan speed, but when we then apply the repair to that, so the repair be okay, let's adjust the fan. Um, we didn't get the results we were looking for. Now I did say something kind of weird there. I mentioned a 3-speed fan with a pulley. Typically, if you got a pulley system, you don't have a 3-speed. It's only with a direct drive. Anyway, um, so if it's not the fan, so if we slowed the air down, we still didn't achieve our results. And ultimately, what are we looking for? Well, we'd like to see our saturation a little lower, right? Superheat's okay. I mean, there's nothing wrong with 15. Personally, yeah, sure, I talk about shooting lower than that, but 15 is fine. Subcooling's fine. Discharge superheat, condenser saturation, all those things are fine. But we do have a little bit of an elevated supply air. So we got a couple of more degrees out of that. Let's say it dropped 2 or 3 degrees. It's kind of bouncing between the two. So yeah, that was how we worked through that, but it wasn't our fix. We're still not processing the space down. So what else would we go to next? Let's see, let me catch up on some of these. Oh, I do see this one comment, Steven. Yes, we are hiring. We're in Austin, Texas. You can go to aps-centraltx.com, and there should be a join our team section. You can just send us a resume, and then they will get that to the appropriate people, myself being one of them. Let's see, what's so 15. The space temp, space temp. Well, so space temp we can evaluate is typically it's going to be fairly close to the return air, maybe a couple of degrees lower. So space temp in this particular scenario is 78. So our space temp is 78, and we took return air at the back end of the RTU coming up through the return air airstream. Coil's clean. Yes, the coil is clean. You did a visual inspection, didn't see anything apparent. Coils, there wasn't any apparent buildup in the coil. Nothing obvious to really stand out to you. Now, that doesn't mean that the coil didn't have an issue, but let's say the coil was dirty. Let's chase that line of thought. If you're thinking about that as, okay, how do I rule out a dirty coil? And then specifically, I'm assuming you're referring to the evaporator coil here. Well, the first two things we could look at would be the evap saturation. So we're running 48 degrees of saturation with a 15-degree superheat. If we have a dirty coil, which means we're running a low airflow typically, or even if, say, the airflow is not low, but our heat transfer is impeded. So we're not able to transfer heat into the coil because we're not able to add it in properly. But we're still moving the airstream. Well, at that stage, we're going to see the saturation and the superheat significantly reduce. So, but in our particular scenario, normally we're shooting for 40, 45 degrees saturation, and we're looking more like a 48. So we're a little high. So in terms of the coil cleanliness, if you don't see any visual issues with the coil and you've got readings like that on your evaporator, it is a pretty strong indicator that that's likely not your current issue. Uh, let's see. Well, you're not getting proper heat removal. Where can economizer? You can use capillary tube instead. You can use a capillary tube instead of TXV. John, Samuel, I'm not sure what you mean there. Okay, so yeah, everything, HVACR, come back says economizer. We are assuming the unit is sized correctly. Yes, let's assume it's been sized correctly and has been functioning this way for some time. So we got an economizer thrown out there. I didn't ignore that, or I technically ignored that earlier. So let's work through the economizer piece of it. All right. In case you're not familiar with what's being stated there, so the economizer on an RTU like this is going to be where we can draw in outside air, or we could do like free cooling. So if our outside ambient gets below 55 degrees, for example, outside, then we can open up the outside air dampers, the economizer dampers, and by doing so, we can bring in that cold air from outside, or the cool air, uh, without having to run the compressors. And so there'll be an economizer control board in there that will activate that, open those dampers up, and that'll get us cooling into the space um, without having to use mechanical cooling, which is referred to as free cooling. Now, the other side of that is, okay, well, what happens uh, when that gets stuck open, for example? What does that do when we've got a 100-degree day and the economizer fails? One of the things that's really tricky about this is I said I took my return air reading and this was a little bit of a tricky scenario. But I took my return air reading from the actual, like on the lower end of the return chase where there was a port down there, or, you get the little pilot holes where you can stick your probes into. So that's where I took um, the return air reading from. Well, a lot of economizers, that economizer air blends in higher up into the airstream. So if you take that reading right there, which in a normal situation is perfectly fine, but when you end up in a spot like this, we need to think about where we're taking our readings. And this goes back to the visual inspections as well. But our temperature probe didn't catch that our actual entering coil temperature was much closer to 90 degrees after it had mixed with the return air. And that was where we're pushing a lot more of our temperatures here. So again, I know it's a little bit of a tricky scenario, but those who've seen it enough times recognize that, okay, if it's not an airflow issue, then with an RTU like that, your next go-to is what's the outside air damper doing? What's the economizer doing? In this particular case, it could be a couple of things. So whether it be mechanical dampers got stuck open, it's very likely that that could be the case. Um, Another issue could be maybe somebody programmed the economizer controller wrong to where it's trying to open for humidity, or maybe the humidity sensor went out, and so it's trying to use some kind of I forget the specific terms, but it has the ability to monitor mixed air and outside air humidity, and then try to use outside air to treat the indoor air to help improve the humidity on the return prior to going into the coil. It's not something I personally use very often, but it does exist out there. So there could be a sensor issue with that. You could have had a sensor failure. Um, the One of the kind of offshoot ones where, say, it's not a true economizer, but it has an outside air damper input. Enthalpy, thank you. Yes, the enthalpy control, it's able to measure that and then decide if it needs to introduce outside air to help reduce the enthalpy in the airstream due to efficiency. It all comes down to efficiency. Uh, Kind of hence the term economizer, economy. Anyway, so in some scenarios, you may not have an economizer at all. But what you will likely have is, like, especially I think it's the carriers that I'm thinking of. They've got a panel on the return air section that you can loosen some screws and adjust it up and down to give some fresh air into the space, because we should, especially being a commercial, we should have 10%, at least code for us, 10% fresh air being pushed into the space. So we always have to think about that, and a lot of the times that gets kind of eyeballed. So that may be something else you think about is whoever set that damper, did they do it correctly? Um, but sometimes those screws too can rattle loose, and when that happens, it'll make that damper section fall, and you'll start introducing way more outside air in than you meant for it. And that can be just normal vibration happening over time. Anyway, in this particular case, yes, outside air damper ended up um, getting stuck open, was introducing a really high humidity and sensible load into the coil that ended up just being more than the system could handle. Because ultimately, it's, in terms of cooling, like it's moving refrigerant. It's got plenty of it in there. It's trying to do its thing. It's just having more heat inputted than it can possibly process. That's really what it comes down to. Now there was one comment I saw earlier on. Let me find it. What's the difference between flash tank and economizer? Uh, Flash tank and that's going to be getting into a chiller chat. So flash tanks are just is York's word for economizer. It's really all they're doing. They're just an economizer. They just call them a flash tank. I think Frylock said could be high latent, higher up. Yep, right there, high latent load. So yes, that kind of goes into the economizer conversation. Now, you may have initially thought maybe high latent load in the space, and that could very well cause it. So this was a kitchen or a laundromat, something like that, where we have really high indoor latent loads. You could see a similar condition to this if you would have, and even still, because the outside air damper was stuck open in this scenario, even if you took readings down in the space, you likely would have had elevated latent or wet bulb or relative humidity levels, because just again, the system couldn't process enough of it out. So it's those kind of things that could really easily mislead you. You may be thinking it's some kind of issue at the space level, when in reality, because it's not always, these economizers are not always obvious. And until they burn you enough times, it's something I've just learned to naturally check. When I walk up to an RTU like this, and I'm having any kind of cooling issues, when I'm doing my visuals and I'm doing my hearing checks, uh, very first things I do is where's my economizer at and what is it doing? Um, because yeah, you could spend a lot of time with a system like this trying to troubleshoot it and get absolutely nowhere really quick. Okay, let's get the next one booted up here momentarily. Okay. Free draw returns above ceiling can affect in the same way. Yeah. Yeah. Okay, let's get into this next one. So, uh, yeah, that's some really weird numbers. Ultimately, the call is not cooling. Pretty typical for this time of year. So you're lucky to get much more than that. So we get on site, another RTU 5-ton package unit on the roof. EVAP saturation is 10. We have no superheat. Um, we outside air ambience 100, return air is 80, supply air 75. Our condenser saturation is 115. Now, the reason I don't show a discharge superheat or a liquid line subcooling, but I show everything else, the system won't stay on long enough to get those readings. So it comes on, it runs for a matter of a minute, if that, and we trip out on low pressure switch. So when it is running and it does turn on, these are the numbers that come up during that time. But again, because we weren't able to stay online long enough, we weren't able to get a reading on the liquid line or the discharge subcoolant superheat. Let's see. Oh, I see Archer's asking about the coffee. Yeah, the coffee is still kind of a no-go for me, by the way. Um, yeah, I've gotten to where I can occasionally drink it, but yeah, still another thing. I'm very much on a Earl Grey kick now. Iced up coil, no airflow, overcharge, C corrected. So let's just pick a couple of these. I see a couple of them coming in. This is great. So this is the process. Okay, what do you see? What's a pattern? A lot of this does come down to just pattern recognition. Pick something, troubleshoot it. So let's troubleshoot overcharge. With an overcharge, I know you corrected yourself, but I'm going to run with that one for a moment. Why is it not an overcharge? Ask yourself that question. So what would you expect to see with an overcharge? We'd expect to have high head pressures. We'd expect to have really high liquid line subcooling. We would also expect to have a really high saturation, evap saturation, and we would expect to see a very low evaporator superheat. So we have the low evaporator superheat, but what we lack is our evaporator saturation is quite low, and our condenser saturation is also fairly low for what it is. And most of the time with uh, with an overcharge, you're going to be looking at a high head pressure trip before you have a low pressure trip. So a reminder, in this particular scenario, we are tripping on low pressure within about a minute of turning on. Airflow on the evap, airflow on the evap, iced up coil. So iced up coil and airflow on the evap. Let's say on the iced up coil piece, that's a visual check. We walk over, we do a visual inspection. There's no ice on the coil. So we say no airflow on the evap. Okay, so let's chase that a little bit. The fan's running, we can hear it. We walk around, we're going to say it's a single speed motor, so just a regular single speed 1775 with a belt. The belt's got good tension on it, it's in good shape. The pulleys look good, the blower's clean. We don't see anything visually on the um, uh, I'm sorry, we don't see anything visually on the evaporator, coil, and the filters are in decent condition. So we just did an overall airflow check on that. And this was a real scenario for me, by the way, not that long ago. This is one this is a little bit of a tricky one. I'm just going to tell you now. Okay. Uh, so we did a walk around check on the airflow system. We even did we're below RLA on our blower. So RLA was 2 amps on the RLA, and we're pulling about 3/4 of an amp. Let's see. Restricted metering device. Okay, so metering device is restricted. So we could rule that out. How, or can we? Is that a real possibility? Well, the thing about it, restricted metering device, that means that in the simplest form, we're going to have uh, low flow through the evaporator. It means the evaporator it's not going to get proper refrigerant. So if we're not feeding proper refrigerant to the evap, then our saturation is going to be high, or no, I'm sorry, you are right. Saturation would be low, but our superheat would be high. So that's one of the major indicators we could use. And it's also very likely we would run an elevated head pressure. In this particular case, we do not. It's not guaranteed. Just because your metering device is restricted, depending on your line set length and such, you might not see a whole lot of elevation on your condenser pressure, especially after a period of runtime. But in this particular case, the fact that we have no suction superheat is a really strong indicator that we're getting fed by the metering device. Let's see. This TXV is failed closed, so it goes back to restricted metering device. Our suction superheat, so in terms of just walking through the scenario, that's going to be your big number that can tell you if it's closed, it's not feeding. If it's not feeding, I can't have zero superheat. So you could rule that out that way. Indoor fan belt broken. So when you did your visual check, the fan belt and the pulleys all were in good condition, and they had a proper tension. Nothing stood out to you as an issue. Pumping down, something is not flowing right. I agree. Dryer or metering device, or you're out of gas, possible leak. Okay, so dryer goes back to, say the metering device conversation. We would have low saturation, yes, but our superheat couldn't be flooding. Like at this point with a zero superheat, you've got a full-on flood of that coil. We're gonna have liquid refrigerant coming back to the compressor. A question that hadn't been asked, but a piece of detail I'll give you. You're seeing it ice up on the suction line for just a little bit of time. It will run. You're seeing a rapid hard frost form on the suction of the compressor. So if you know what that means, that'll help kind of give you some direction. And in terms of out of gas or possible leak, um, that is a possibility that goes back to underfeeding the evaporator. But the number one thing we keep coming back to we know the evaporator is not being underfed because of our suction superheat. Going the right direction in terms of, the blower. Is the blower going the right direction? Yes, so we did a shutdown. Part of that visual check is we look at our blower, what direction is it naturally spinning. We even bump the blower just to see the rotation direction, and it is spinning the correct direction. Uh, Willed install backwards. That's a pretty good one. That one can be tough to check. Again, though, we're happy with the blower itself. Nothing stood out to us. Now that could be one. That is one of those things where that is a real possibility that somebody install it the wrong way, and unless you just know, that can be hard to troubleshoot. That can be real hard to troubleshoot. Now, one thing that I would challenge you is what would make you, what have you seen so far, and what have I said that would make you think that it might be installed backwards? What made you think that and take you that direction, or is it just a shot in the dark? I mean, it's okay if it's a shot in the dark. It's a direction. That's part of the thing I wanted you to take away from this. Have just a direction. Pick something and troubleshoot. If the airflow is good, it'll be the metering device. So metering device, it's either underfeeding or overfeeding. That's your two options you have, other than properly feeding. It's not properly feeding, and it's not, um, if it was overfeeding, we'd have evap superheat of 0, yes, but our evaporator saturation would be significantly elevated. We have a return air of 80. So I'd expect, high 40s, 50s with a really overfeeding valve. On the other flip side of that, if it's restricted, the superheat's not going to be low, it's going to be high. Let's see. You won't see high pressure all the time. Yep. As restrictions won't always cause high pressure. Yes, that is correct. Superheat would be high. One side of the evap is restricted. I think I forgot a T. One side of the evap is so only half of our coil is getting refrigerant flowing through it. That would be an interesting scenario. That I might steal that for a troubleshoot one day. Okay, so how do you troubleshoot that? Let's take that for a moment. That can happen. So if we had a real condition like waxing, let's say we had a waxing condition, and it was one of those, whether it be microchannel or those real small, like, was it 5/16, 5/32 pipe coils. I had several condensers that were piped in that small coil size, and the compressor ended up overheating and the oil ended up waxing, and it would plug up those tubes. I've had to pull liquid lines out before and ream the coil out on the inside of the tube because it was full of wax. Anyway, so how would you troubleshoot that? So what would I expect to see? Half of the coil is getting refrigerant. Let me see if I can do this on the spot. Um, well, I wouldn't. So if we were truly restricted to the point, so at that point we wouldn't have flow, or it would have such a heavy internal lining with the waxing. so that it couldn't transfer heat. Okay. And they've had this issue. So at that point, this would have happened over a significant period of time, and they would have just not reported it until recently, which happens all the time. Um, okay. So let's say it's not a full-on restriction, but it's got an internal coating. What would I expect to see? I would expect very similar to what I have. We'd be flooding. We'd have a low evap superheat. Um, we would have very low return. I'm sorry, split across our evaporator. But I don't know. Hmm. I mean, it could get that extreme. That'd be a lot of wax because it would almost act like an oil log is what it would do, because the oil logs evaporator will do basically the same thing. The oil's insulating the inside of the tubes, and it's not transferring heat properly, and so it'll it'll do this. Well, an oil log you can help overcome by increasing velocity, right? So let's take that approach. If I was to address an oil log, then I would manually control my head pressure, and I would force the compressor to run at about 130 degrees of saturation. That's going to get our velocity up and our head pressure up. It's going to add some extra heat into the system, and that's usually enough that I can force the oil back out of the evaporator after several minutes of runtime. But that's not going to fix waxing, because waxing, we've actually congealed a what used to be oil on the internal of the system. So I guess that would be really hard. That'd be hard to figure out. You'd end up probably having to break open something. And honestly, technically the metering device would be the first thing to catch it. The Whether it be a fixed bore, because I've had that happen. I've had wax build up on the pistons, and I've had to pull them out and clean the bore out in there so they can flow again. So I've had that happen. Same thing at TXV. I'd expect um, the screen coming into the TXV to catch most of it, but in a really extreme situation, maybe it doesn't. Maybe it gets past that. That'd be a tough troubleshoot. So what would be the final thing in a scenario like that would make you um, decide? So I would approach it as if I had oil. I had an oil logged evap. Um, Addressing the oil log and doing my normal procedure. When that didn't correct it, I'd be sitting there scratching my head for a minute. Uh, hmm. We're going to be icing up on so the coil is going to frost heavily because we're not exchanging heat, and because we're flooding back so much to the compressor. You're going to have a very frothy, white frosting. It's not going to be a hard frozen ice. That happens over time, and accumulates. With a low coil or a low charge or underfed coil does that. But if we're having a hard flood, we get a almost instantaneous, like just frothy ice build up on the lines and in the coil. Um, yeah, I'm not sure, to be honest. Now like I said, I don't know if that could ever even happen. Maybe somebody's had that happen, but I'd have a really hard time if we waxed the evaporator, coming to that conclusion and feeling confident about it. At some point, I think I would just end up chunking out there that something has gotten into the evap, especially if I've already verified my airflow. Oh, okay, so there you go. Thinking through that, then I would really start to question my airflow. If uh, so at that point, I'd want to take an external static. So if I had worked out that the airflow was okay and my external static was proper across the coil, I just wasn't getting the heat transfer. Then it just comes down to it won't transfer heat. It just heat transfer is heat transfer. If it won't do that, then we have to condemn the coil. Anyway, that was a That's a pretty interesting one. Okay. Let's see if the blower is pulling little amps. Could it be that it's dropping off or lost its voltage? I'm glad you picked up on that. Okay, I'll give you a hint because this one's taking a minute. Yes, the blower is pulling low amps. If you heard what I said earlier, I said it's a 2 amp RLA and we're pulling 3/4 of an amp. But I said everything else is doing fine. That is a key piece of info there. So why? Why are we pulling so low on our amperage, even though we got a single speed blower and it's running, it's tensioned properly, everything seems fine, coils are fine. Um, in terms of losing voltage, okay, so we measure our voltage. We're going to sit there with our meter and we're going to monitor it for a few minutes, just taking a continuous reading. And the voltage per our meter seems stable as we could verify in the field. So we could rule the voltage piece of it out that way. But at the same time, if it was a voltage issue, we would also see our current draw fluctuating as well. So in this particular case, our voltage is stable and our current draw is stable. Neither of them are fluctuating or changing much in any way. And I see I'm getting way behind on the comments here. Not running long enough to determine pressure. How long does it run? It'll run less than a minute, or right at a minute. Look for oil stains. We did a visual walk around. No obvious oil stains anywhere. If the suction freezes quickly, then the refrigerant is not picking up any heat, and the blower speed is too low. But we've got a single speed blower, and we've got belts and we've got belts and pulleys. Everything's tensioned right. There's no major wear on the pulleys. It's all spinning. It is spinning. But I agree with your statement. Well, that was some information missed out. Icing up on the suction line. Yes, the suction line. And I didn't make a dramatic thing of it earlier. I kind of quickly moved past that. But yes, the suction line is frosting up to the compressor. Evap filled with oil. So, okay, so let's say we had an oil issue. That particular case, we're not running long enough to really. It would be hard to address that given our running state, but we would do the condenser fan test like I described earlier. So pull the common leg off it. So say we got a single phase condenser fan. Pull the common leg off of the contactor with a pair of needle nose, let the head pressure rise, and then manually cycle that fan. Not the safest procedure in the world, but it works. Cycle that fan to maintain the head pressure. You become the fan cycling switch at that point, and get your velocity up, get your head pressure up, and see if that oil will move out. We say we went through that process, and the we didn't have any change. Nothing changed by doing that. So if it was oil, I would have expected those readings to change after maybe 10, 15 minutes of doing that. So we got a low side restriction. Okay. So if we have the restriction in the suction line, there's no obvious restriction. Being an RTU, we can trace the suction out. It's all visibly there. There's no suction line filter dryers in place. It's straight pipe. Other than a couple of bends, there's nothing obvious. If we had a low side restriction, I wouldn't expect, like you could see the evaporator saturation dip like that, but I wouldn't expect my superheat to be that low with that. Bulb wasn't mounted right on the suction line. Okay. So if our bulb's not mounted right, means we're reading ambient air, which means we're going to overfeed. Yeah, we should overfeed if the bulb's not mounted and insulated properly. At that point, if we're overfeeding, our evaporator saturation would increase, not decrease. So the fact that we're running 10 degrees It's no good. Um, if it's not something to do with airflow, I'm becoming a I'm not trying to make you question your life, but uh, it'll make sense when we get there. Actually, I think somebody's technically guessed it already, but I did purposefully move past it. So I wanted to keep this one rolling for a minute. Because no superheat, that's what I thought. Airflow problem, refrigerant is feeding. Okay, so I see as I'm catching up on the chat here, oil log was my next guess. Everybody's really um, uh, honing in on some kind of airflow thing. But yes, we've had it said. I've seen it twice now, actually. Quit ignoring me. Yes. uh, so one of the visual checks we have to do sometimes is the duct itself. Uh, in a small RTU, it can be really difficult to do that. But in this particular case, yeah, it all comes down to airflow. Um, One of the things, I talked about taking an external static on this system earlier on to verify flow through the coil. Um, but that was referencing the waxed evaporator specifically. In this scenario, nobody ever asked about what our external static was. That itself, like in terms of, I kept referencing like we're doing a visual inspection of the airflow. Everything visually checks out fine, but how about we take some readings? I'm not giving you everything, all the information there is. I want you. I'm trying to pull it out of you anyway. Um, so you'll started to pick up on the amps, but I didn't see anybody ask about static. Nobody asked what was our external static across this RTU. Ultimately, our external static is crap. Um, that would have been the indicator to tell you that, okay, we have no flow. We have low amps on the blower, even though it's spinning fine. We have low external low should be low external, high external static. Yes, we have a high external static, meaning that the higher that static goes, the less airflow you have. So we have a really high external static, and um, uh, you could do something as simple as, the filters. Do the filters suck up to the coil, right? If you didn't have a manometer up there with you. So if you pull the coil out or filter out, and then just does that, or a piece of paper, does the fan actually move air in some way? You could do some physical checks to determine that. Um, or yeah, door pull test. That's another great example. Does the door fight you to get it off? If it doesn't, and it just pops right out, well, again, that's just there's not any air moving. That fan is spinning all at once, but it's not pulling any current, which means there's no load on it, and that blower is just literally spinning its wheel. So, uh, at that point, we have something outside of the unit causing our problem. Fire dampers are a really big pain in the butt to troubleshoot sometimes. In this particular case, I spec'd it to where your supply side duct had a fire damper closure. So with a larger RTU, a lot of times you can see down, and you might even be able to see far enough to see that fire damper. When I've had that happen in the past, that was usually the case. It was typically on a larger system, and I was able to just visually see it after spending more time than I'll admit trying to troubleshoot it. But in some cases, you might have to go down into the space, and so this would just speak to you as a ductwork issue. So we got something wrong in the ductwork. We're going to go down to the space. Let's do a visual inspection of our ductwork. Do we have a damper closed? And getting back to here, we have a fire damper that it went bad. The fire damper went bad. The actuator failed. Those spring close when they fail, and that ends up blocking up your whole supply airstream. And yeah, you'll have exactly this. It'll come on and it's going to trip off on saturation or on low pressure because it literally has no airflow at all. The fan's spin all at once, is not moving anything. Okay, that was a good one. Uh, yeah, I think return damper should I see that. The system at blank off or backdraft dampers. That could be one, actually. In some larger applications, you could have something like that, especially. Um, I saw it. I purposefully passed over. Y'all, a couple of y'all guessed that way too early on about the fire damper. I was like, nah, I'm not. I'm not giving you that. We're gonna push this a little further. So I appreciate everybody sticking around. That was a good one. Really enjoyed that myself. That was a good chat. Hope this is helpful. I hope you got something good out of it. APS guys, if you have any questions on this or if you have a follow-up, feel free to give me a call, send me a text, reach out. We can chat more about these. We can go into a little more detail, or if you have your own specific questions, we can work that out. I did see it come up a handful of times about um, hiring here at APS. That's what these classes are. I'm doing it through the HVAC Time YouTube, yes, but ultimately this is just genuinely the best platform for our team to get these trainings out there and to do this webinar style thing. Anyway, if you are interested in applying with us, we are currently hiring. It is aps-centraltx.com. You can send in your resume there. I think you can actually submit an online application or get the form or something like that. Um, yeah, stay safe, be careful. Opinion on changing mineral oil to POE. Make sure you flush. I'm fine with doing it. It's something we've had to do for many years, especially when 407 was really coming out and you had that became really popular. I am a proponent for 407C. I like that one, um, but you have to really flush that system and you have to be really meticulous. And you can't just dump or drain it out and purge and then slap it in there. You're going to create problems for yourself. So make sure you clean the system. An R22 can run on POE oil. Uh, Very helpful. Da, 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 da. Yeah, absolutely, guys. All right, we're gonna close it out. Stay safe. I'll catch y'all around.